So it's also equal to minus 130 megapascal. Okay. So the other possible value is at minus 130, right? So I'm going to draw another circle, and this circle belongs to XZ plane. Okay, so it's at 50 to 50. So this belongs to the XZ plane, and this is our out of plane. Now this solution is valid because what you realize is this, okay? The tau max, maximum shear, is still equal to what? 75 megapascal. But the maximum shear occurs in the what? YZ plane. Okay, the maximum shear occurs in the what? YZ plane. Now, some of you might consider, Eugene, why when I started with this line? Yes. What if we join this at point X to point 0? Will the solution be valid? Okay. So let me draw what I mean by that. Okay. Let me draw. So I'm going to draw that out. Okay. So I'm going to, do we have space? Yeah, I'm going to draw on this side. Okay. Okay, let me see, do I have space? So it's 75. So if this is 80, 60, 40, 20, 0. No. I'm going to start on a new page. I do apologize. I was being silly over there. Okay, so let me highlight what I mean by this explanation. So let's say now we have minus 160, 140, 120, 100, 80, 60, 40, 20, 0, 20, and 40. And then we have our normal stress. Okay, so this is our normal stress. Then we have 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80, element rotation clockwise, anti-clockwise down here, and that is our shear. Okay. Then if I were to draw a box to bound our U strength, okay, I'm just going to ignore the left hand side. Okay. So now then we have our again our minus 70 line, and then we have our 40s, right? So now, so this is our point X, right? So this is our point Z. Okay. So remember we started the previous one. We started by this yellow line. It goes to the minimum, right, at 150. Okay. What if now is the solution possible if we draw this first? Okay. So watch this. Okay. What if now we do this? Right? It can either go left or right, like what we had before. Okay. So now once we draw this, we apply the rules of the circle. Right, then we're going to have rotate by 90 degrees, right? So from here, we have a new value of our stress A now. Okay, so we find our stress A. So we know over here this angle is alpha. This angle over here is also our alpha, right? So tangent alpha, right? So we have tangent alpha is equal to 40 divided by 70 now. So alpha is equal to 40, 70 inverse tangent is equal to 29.7 degrees. So we can find our stress A, right? So stress A is equal to minus 70, right? Minus because it's going to the left-hand side. So it's equal to 40 tangent 29.7. Okay, so this will be equal to tangent 29.7 times 40 plus by 70, so it's equal to minus 92.81. Okay, so this is minus 92.81 megapascal. So we can find our stress average is equal to minus 92.81 plus by 0 divided by 2, right? So 92.81 divided by 2 is equal to minus 46.405. Okay, so I'm just going to eyeball these. Okay, so minus 46.405. Okay, minus 46.405. Okay, so it's somewhere around here. So now we can construct a circle now, right? This circle we construct, okay, belongs to our XY plane, or more than that. Okay, so let's construct a circle because we know where the center is. You have protractor, you construct a circle. So 46, and then 46. Okay, so this is so we draw another line across the stress average line, right? So once it crosses, this is our point Y, right? So this answer is okay for now, okay? But I'll tell you what. So let's calculate what is stress Y, right? So we know that this is alpha, right? If this is alpha, again, center of the circle over here, this is our 2 alpha, and over here this is our 2 alpha, right? Because this is our alpha, right? So this, why? Because these are the radius of the circle. Okay, so now we can have so stress Y is equal to minus 46.405, right? Like the previous one, right? Then you're going to plus 40 divided by tangent 29.7. Okay, so this will be equal to 40 divided by tangent 29.7. Okay, so 40, hold on, 70. I'm having, wait, let me do something. It's the tangent that's throwing me off. Tangent, tangent 2 alpha, yeah. No wonder it's throwing me off. Okay, so tangent 2 alpha, so 29.7 times 2, tangent of that, so 40 divided by Yep, 46.405 minus by, so it's equal to 22.749 megapascal. Okay, so there is, so we found. Now, why is this answer not valid? Anyone? Okay, so let me show you what is the what is so unique about this circle over here. Is this a 2D Mohr circle or 3D Mohr circle? Anyone? Whether, yep.
2D? Is it 2D?
2D is 3D. Why? Because point X, point Y, and point Z are all on one circle. It's still 3D, but all three circles are superimposed into one. So this circle over here, right, belongs to the XY plane. It belongs to the YZ plane, and it also belongs to the XZ plane, right? Because all 3 points are not one circle. But this solution is not valid. It's because tau max is not equal to 75 times 10 to the power 6 Pascal. Right? Because that is one of the critical component. That your tau max has to be what? That your tau max has to be what? 75 times 10 to the power 6. Okay. So if you look at the second solution that we have done, I know I'm jumping everywhere. Our answer is what? Minus 130 is valid. So if you look at the solution manual, okay, it's also equal to what? Minus 130 is the valid answer. Okay, but they can form all these formulas, okay, and don't do that. Okay, you want to figure it out, help yourself. I would rather draw the circle, and there you go. Okay, so basically this equation that they have written is the rules of the circle. Okay, but why bother? Just draw the circle. Okay, that's all I have for today. Okay, I will still stay behind if you have any other questions. Okay, thank you.